Okay, Pythagorean triples. All right, so a lot of times we come up with 3 whole numbers on a right triangle. Santosh. 3 right triangles, 3 whole numbers, right? So that's called a Pythagorean triple. We just seen one. It was a 3, 4, 5 triangle, right? So that's one type of Pythagorean triple. These are 3 different types. Okay? So, how would I find C in this case? Now C, in all 3 cases, we're going to find C. And then we're going to start, yes sir.
I forgot where to print this.
Oh, thank you sir. Focus. Okay. So what does C squared equal?
For that one, it equals, I don't know. Oh, 23. 23, I think.
8 squared
I have no clue. I said.
plus 25 squared. Or I'm sorry, 15 squared.
That's why I guess.
Right? Because it's A squared
I think.
plus B squared equals C squared. Right? So we plug them in. Definition of Pythagorean theorem. Right?
Yes.
Substitution. Right?
Yeah.
Then what?
Simplify.
Simplify using what?
AS.
Uh-uh.
Oh.
Exponents finally. We've never used exponents yet. Yeah, have we?
No.
Okay, so what is 8 squared?
64.
What's 15 squared?
3, 2, 25.
Okay?
You really got that.
Alright, so now we use simplify
Yeah.
AS, right? Now you see why we're using these AS versus MD versus E? Okay? Now, C squared is equal to what?
289.
3,
2,
289.
okay?
So it's equivalent. That's not. That doesn't seem.
And so then what?
And then you have to find the square root of that.
Yes, you find the square root of this.
Got the hiccups there?
So that's what? Simplifying using what?
Division and stuff.
Ah,
And B.
I have no clue.
you are correct. It's not simplifying. We did it on both sides, didn't we?
It's division property of equality.
It's not division property of equality.
It's
Square root property of equality.
yeah.
I think equals estimate.
We finally get to use the exponential property of equality. Right?
Yeah.
It's actually, we're finding the inverse of the exponent. Believe it or not. Believe it or not, what we're doing here is we're saying that C squared to the 1/2. What's 1/2 of 2?
1.
1.
1/2. Oh, 1/2. Oh.
Is equal to 289 to the 1/2. So that means C is equal to 289 to the 1/2. Right? What's 1/2? It's just a square root. What's 1/3? A cube root. What's 1/4? A 4th root. Okay? This is what you'll be learning next year in Algebra 2. Okay? But I'm showing you this right now because you need to know this to do square roots. Now, what goes into 289?
17.
17.
What?
So C equals 17.
Precisely.
Exactly.
This guy looked it up. There's
I guess 16 when it was.
And we use this property to find it. So if you put it in your calculator and go C squared, right? You would get this. If you get 289 square rooted, you would get 17. Now I'm going to also show you how to do things without using the calculator to reduce your square root. Yes.
My God.
The half is the square root.
Oh. Okay.
So what it is there's a power
Yeah.
and there's a root,
Yeah.
right? It's 289 to the first power to the square root.
No, everything.
There's a hidden 2 right here.
Okay.
When you do a square root, there's a hidden 2. And you'll notice that later you get cubed roots. Well, that equals to the 1/3. Guys, stop talking. I can't explain over your voice every single time. It's very annoying. And when you go to watch this, you're going to see how annoying you really are. Okay? Now, so what is a 1/2 was just explained 4 times. I want you to look at this video. Look at this video and rewind it and watch it every time I said it. And think of how annoying it is to say that to you 4 different times because you can't hear or you're not listening because you're talking to somebody else. And then listen for your voice. And I guarantee you, 3/4 of you, you're going to hear your voices. Because 3/4 of you were talking while I was talking, which you should not be doing. It's disrespectful. Okay? Alright. Enough said. Alright, so let's move on to the next problem here. Okay? So to be able to do this, again, it's to say, and I'm going to save this for last because I won't have enough space, right? But I'm still doing the a squared plus b squared equals c squared, right? Definition of Pythagorean theorem, okay? And then what do? I substitute in the values that I have. And in this case, I still only have a and b, right? The c is the one missing. The c is always the hypotenuse, okay? So that's something that you're going to be learning about right now is hypotenuse and 90-degree right triangles, right? And then later on in the year, you're going to be learning about 30, 60, 90s. So really intense stuff. Sine, cosine, tangent.
So
Yes, ma'am.
Like, if you have A and C, you can't be like C minus A? You can't do that?
Yes, you can.
Oh.
Yep, absolutely. And we're going to do that one next.
Okay.
Right? So very good. Yeah. Okay, so let's plug these in. So we have 7 squared plus 24 squared equals c squared, right? And so that's substitution. And so what's 7 squared?
49.
49. And remember, we're using the simplification of what?
The exponent.
Exponents. Good job. Okay? And then what's 24 squared?
460.
Bro.
Anyone have a calculator? Good. I know that 25 squared is 625, right? So 24 squared.
You said 20.
Oh. 24
I
squared.
was way off.
What is
576.
576?
Yeah.
Okay. 576. Sorry about that. I usually have these memorized. 576. Okay, and then when we add these up, what do we get? Oh, 625, huh?
625.
Right. So I get 625 equals c squared. And then if I want to do, again, if I square root both sides, or in essence, what am I doing? Taking it to the 1/2, right? 1/2 of 2 leaves 1, right? So when I'm taking it's the square root property of equality, or we could call it the exponential inverse property. That's a little bit more precise, right? I don't care which one you use. You can say it's just the square root property, because that's all you guys are going to be doing. But later on in Algebra 2, you'll be learning that it's an exponential inverse property. You'll be using like the exponential inverse. So in other words, if you have something that's like 5 to the 3 halves, to take the inverse of it would be the 2/3, right? So now you're going to be doing cube root. So this is really 5 to the 3rd power square rooted. If you wanted to make that 1, then you would square it, right? And then do what? Cube root it. Because you'd have 5 cubed inside there. So once you squared it, you get rid of the square. And you cube root it, you get rid of that cube, and you just have 5. The inverse exponential property, right? So, I know it's a little bit much right now, and you guys aren't really ready for all that. These are just seeds I'm planting in your head. But what's good is to realize that this is just the square root of this, and that's going to be what, 25? Right? 25 times 25 is 625?
Yeah, I need that.
So, it's good to start memorizing some of these squares. So let's go over a couple squares that you might need to know, right? Because you already know 7 squared, right? 8, 9, 10, 11, 12, 144, right? But what about 13?
Is that like 150 some?
13 squared.
156.
169.
Oh, I was wrong.
These are my favorite, 13 and 14. 169 and 196. So they're kind of like inverses of each other, right? Okay? And then 15. 225. 16.
256.
256. 17. We just learned that one.
289.
289. 18. So I used to have it up to about 22, right? Now I haven't taught in like a year and a half or whatever, so I'm kind of stuck at 17 here. But I think 18 is somewhere around 2 or 324, maybe. It might be 324. You'll have to check.
Okay.
Okay. And then there's 19, which might be 389.
19. 361 is 19. And then
So 18 times 18 is 324.
so you're right.
And 19 times 19 is 361. My bad. So 19 and 19, 361. And 20 and 20. 20 is an easy one. Come on. 400. Okay. And then 21, 22. But I think we can memorize up to 20, right? And that'll help on this test, okay? I'll try to make something less than 20, okay? So we can do these things.
Are we still not allowed calculators on the midterm?
Yeah, I don't think so, but we'll decide. Maybe I'll let
I
you.
feel like it's an unfair advantage to the other classes.
What?
To the other classes, yeah. But that just means you're smarter than them.
Not if we mess up and we do it wrong.
So I'm going to pause this video and then we'll start again, okay? We'll pause this video. We'll start on 12, 6, and 12 and 16. Okay? All right.